Mathematics promises certainty, but at the cost, it seems, of passion. Its initiates speak of playfulness and freedom, but all we come up against in school are boredom and fear, wedged between iron rules memorized without reason. The Art of the Infinite, Robert Kaplan and Ellen Kaplan. Do you see math as creative? Do you see it as play? If phrases such as bedmass, cross multiply, or the circumference equals 2 times pi times radius come to mind instead, dare I say it, you didn't even learn math at all. I know that's a pretty bold statement, but as Paul Lockhart says in his paper, A Mathematician's Lament, mathematics, like any literature, is created by human beings for their own amusement. That works of mathematics are subject to critical appraisal. If this statement doesn't make any sense to you, or doesn't line up with your own experience of mathematics, consider this story, found at the intro of the very same paper. Consider a parallel world where music is made mandatory in school. Society has decided that music must be learned from kindergarten to grade 12. A commission is formed, curriculum produced, and not one working musician is consulted. Students start by learning how to draw notes on a page. They must learn how to properly place their notes and spend the first few years learning the notation, and proper penmanship is paramount. One student comments, "We copy straight from the board, and our notes must be exact. One time I converted between key signatures correctly, but got no credit since I drew the stems pointing the wrong way." It is soon discovered even young kids can learn this system of drawing and manipulating musical symbols according to established rules. Students are shamed if they haven't memorized their scales by grade 3. One parent laments, "I am worried my son is falling too far behind. He doesn't apply himself and spends the day humming silly songs that he makes up while daydreaming." Students spend their high school career learning intense theory, but never get to hear any music, let alone create their own. Those truly gifted, those that can create perfect representations of established works with perfect penmanship and proper notations, those are the ones that get to go on in post-secondary and get to hear the music they've learned about, and perhaps even create some of their own. "What? Play music?" one teacher exclaims. "You're starting to sound like one of my university professors." No, we'll leave that advanced level of work for those who really get what's going on. I hope this story struck a chord. You have been deceived, treated as a trained monkey to do rote, meaningless work. You are not much better than a computer, and probably worse. You are fed algorithms instead of guided as an artist who has been given tools to explore a blank canvas with color and form. A friend, Christopher, quipped while discussing these ideas, "You don't do the math, you tell the computer to do the math you want it to do." Mathematics is a creative endeavor, but we have been too steeped in the system to see it any other way than, "I like math, there's only ever one right answer." You might be feeling a sense of injustice right now. I know I did. It took 3 years of university education for me to see that I was never actually good at math, and that it is actually a creative human endeavor. The problem lies in the fact that it is almost impossible for most math teachers and students to even begin to agree with this idea. We are usually too immersed in this paradigm to even fathom an alternative. However, a number of years ago, I had an opportunity to teach a grade 6 class on area, surface area, and nets. A net is what a 3D box of a shape would become if you laid out all the surfaces flat, but still had all the surfaces connected. I had the students bring in old cardboard boxes like cereal or macaroni. We figured out how to calculate the surface area of one side and then generalized the surface area of the whole box. Those lessons of area and surface area had been covered earlier. We then measured out that same area on a giant square on some wrapping paper and tried to cover our boxes. No cutting. One by one, the students started getting confused. They measured the area correctly. Why doesn't the paper cover the box neatly? Before the confusion became too much, we got the class together to brainstorm one more possible solution to cover the box without waste and no cutting. Nets! We then pulled the boxes apart and discussed why the boxes didn't fit our model of nets well, such as needing to glue it together. From there, we explored what other 3D box shapes might look like, a triangle prism, for example, and what strategies we could come up with to figure out their respective nets. This example is by no means perfect, and I was trying to meet the students where they were at given their traditional pencil and paper rote learning. Instead of worksheets practicing the surface area formula, we got to put it into action. Students were able to tackle a problem, and students were allowed to be frustrated and come up with their own creative solutions. Many people argue that we need mathematics to be useful, but Lockhart argues we don't study any of the other arts because of their usefulness. If we truly pursue mathematics for the sake of math, any usefulness can be derived as a tangential benefit later. Because in reality, math is fun, or it should be, and education seems to have stripped math of any soul. Students discover this when they enter university. If mathematics education is started out properly, then in the senior end of high school, any vital ideas can be covered in preparation for university courses. And the general population will get to be enriched with their studies instead of traumatized. What do you think? Have you always felt that something was off with your math education? Read Lockhart's paper. What camp do you fall in? Pro or anti-Lockhart? Do you agree with his assessment?